see Lindelof videos, trigonometry, even odd properties of trigonometric functions. But this stuff bothers the hell out of people, just absolutely destroys their brains. But it's actually very, very simple. So first thing I would ask you to do is just to copy these properties, and then I'll describe why a couple of them work, and just understanding why those work will help you understand why the rest work. First off, I'm just going to look at the first three properties. This one, and this one. And I just want you to take a look. Underneath of each property, underneath of each trig function is its reciprocal function. And I just want you to see that the pattern stays the same. So if you know what the even odd properties are for sine theta, then you'll know cosecant theta. If you know for cosine, then you'll know for secant. And if you know for tan, you'll know for cotan. So just something to think about there. What I'm going to do now, if you don't mind, is I'm going to switch over to the unit circle and show you how this works. So I'm just going to kind of demonstrate why this works for sine. So we have sine theta here in blue, and it says that sine of opposite theta is the opposite of sine of theta. So this is going to be my illustration. Let this be theta. Let this be theta right here. So I'm looking at this angle right here. All right? So just to do a little trick with you, we know that if angles open counterclockwise, they're positive. If they open clockwise, they're negative. So look at this for a second. So I'm suggesting to you that this is the theta that I'm looking at. And if I want to look at the opposite of 45 degrees, I'd go opposite 45 degrees would be right here, right? Go straight down to here, right? And that would look like this. Okay? So I'm saying that this is 45 degrees. I'm saying this is negative 45 degrees. So look at this just for a second. So we agree this is 45 degrees, or pi force, however you want to describe it. And if that's true, then this one is negative 45 degrees. Negative 45 degrees. Isn't it? So there are our two triangles. Well, look at the sine value. Remember sine is the y value when you're on the unit circle. So here's that. And look, if I go straight down, if I go negative 45 degrees, look what the sine value is here. So it says here that sine of opposite theta, so sine of opposite of 45 degrees, or negative 45 degrees, is negative, right? Is negative pi hat, upstairs, negative square root 2 over 2, which is the opposite. This is an opposite sign right here. This is opposite, which is the opposite of positive square root 2 over 2, isn't it? It is that easy. And you can chase that thing out with as many as you want. Go to the next one if you want to. Here, say, okay, sine of 60 degrees is square root 3 over 2. Sine of negative 60 degrees, which would be here, right? I'm moving this way. I'm opening my angle this way, would be opposite of square root 3 over 2, or negative square root 3 over 2. Positive square root 3 over 2, negative. I think it makes perfect sense. It doesn't freak me out at all, but it just bothers the hell out of everybody else, because I think a lot of times when professors show this, they're not keeping it simple, and it really is just that simple. Thinking about angles opening positive, angles opening negative, right? So there's this one. So we got that checked off. So let's go look at cosine, and it says here that cosine of opposite or negative theta is the same as cosine of theta. Well, let's look at the same examples we used before. Remember, we're going to start opening from here that way. And when I get to 45 degrees, the cosine value is this one, isn't it? If I open 45 degrees negative, I end up right here, don't I? And if you look, just look at this for a second. It makes perfect sense to me. If you look, this line goes straight down. It's a perfectly straight line. That is to say, we haven't moved left or right as far as the change in x. There is no change in the x value, right? The height changed, but the x value didn't change. So of course it's true that cosine of opposite theta, let this be negative 45 degrees, or opposite theta, and let this be positive 45 degrees, that those cosine values are the same. And that's what this says. It says that cosine of opposite of an angle is the same as cosine of that angle, where we're taking opposite to mean positive compared to negative, where we're saying that if we open an angle counterclockwise, we get positive angular values. If we open it clockwise, we get negative angular values. Again, if we open it counterclockwise, we get positive. If we open it clockwise, we get negative. right? So this is 45 degrees. At the same time, this is 45 degrees. This is also, and I know it sounds weird, this is also negative 45 degrees. And isn't it true that their cosine values are the same? And isn't it true that their sine values are opposites? So that's all we get there. And if you take that understanding of it and apply it to the rest of the trigonometric functions, you see why that's true. So I hope this is helpful, and I hope that you don't let your professors get your brain bogged down on this too much. This is actually relatively simple and straightforward if you look at it from a practical standpoint. So I hope this is helpful. If you have any questions or comments, please let me know. And if you haven't already subscribed, please subscribe.